of keeping your outlet temperature high or low. Maybe I shouldn't show this, because otherwise you'll just read off. So let's say you're trying to heat, right? That's the problem you're solving, right? You want to heat. So if you want to heat, what is the advantage of keeping your outlet temperature very low? Now the lowest you can of course go is the outlet temperature of your process stream, right? If your process stream is heating from, let's say, 30 to 60, the lowest temperature you're going to allow your outlet of your hot water is to go to 60, right? But you don't necessarily, you don't want to go to 60. If you want to go to 60, what's going to happen to area? Area will actually be infinity, right? So you don't want to go to 60, but the closer you go to 60, what will that do to the flow rate required for your hot water? It will lower it, right? Because the larger temperature difference for your hot water stream, the lower will be the flow rate. The lower the flow rate, you will say the lower the cost, right? But what is the penalty? What penalty do you pay? First of all, as we discussed, the area goes up, right? And that's a penalty. What else? Sorry? Well, the energy cost you are paying in terms of the mass flow rate, right? So the energy cost will actually go down. But sometimes the utility company may put a penalty on you. If you are using their cooling water, hot heat water, and you send it back at very low temperature, or if you're using typically more if you're using their cooling water, and if you send it back to them really, really hot, they might actually charge you a penalty. Okay? Also, now this of course is not relevant if you're heating your process stream, but if you're cooling it, if the temperature at which corrosion occurs, right, the corrosion rate is higher at higher temperature. So if you let your cooling water get to very high temperature, you have more corrosion. So the net balance of all these terms, not these pros and cons, is that if you're using cooling water, you let your temperature increase roughly by 15 degrees Celsius. Okay? If you're using, of course, hot water, that is not relevant. In that case, you have to see what is the outlet temperature of your process stream, and you stay about at least 10 to 15 degrees Celsius above that. Okay, so these are kind of rules of thumb that you go by. Okay, so you can see these are the issues. If the return temperature, now this is for cooling water, so some of the rules are actually flipped. But nonetheless, you have the 4 criteria. So optimum temperature increase of cooling water is 15 degrees. Like I said, giving hot water, of course, you should make sure you never approach the temperature, outlet temperature of your process stream. You always stay at least 15 degrees different from that. All right. So now the raw material cost. Again, we talked about it. Look at the process flow diagram. Look at the cost from various sources. You multiply the two, and you have the answer for raw material costs. There are tables like this in the book where you have the cost per kilogram of various different chemicals. It's interesting to see which chemicals are really, really expensive. You don't see a huge difference here, really, but you can see hydrochloric acid is incredibly cheap. Everything else is relatively somewhat similar. The highest cost I can see is, sorry? Acrylic acid, about $2 per kilogram, yeah. But still, you can see relatively not a whole lot of difference, right? Most of these things here are not too expensive. I mean, I already told you about what stream factor is. Stream factor is number of operational years, fraction of days you're actually working. So that's typically 90 to 96%. And so you multiply what you need per year by roughly 95% to figure out how much you're going to actually spend on raw material. Now, if you remember, when you're trying to calculate labor, you did not multiply the cost of labor by 95%. Why not? Sorry? No, we already factored all that in by 4.5. Because even in your maintenance, you still need labor, right? Actually, you might even need more labor. So that's why you don't reduce the labor by that. That's right. Cost of treating waste, I already told you about that. The cost of treating waste can be very, very expensive. These are some rough numbers on what the costs could be. And because these costs are very high, especially if it's a hazardous waste. And the most difficult thing about hazardous waste is, and this actually happened personally to me, I was actually going to set up a unit operation. I was working with a company, Kimray, and they were setting up, I was helping them set up a plant for removing ammonia from exhaust. So they were working with ThyssenKrupp. You guys know ThyssenKrupp? That's a company in Germany that makes elevators, but they actually make everything. Before I started working on this project, I thought ThyssenKrupp only makes elevators, but they make everything. So they actually build fertilizer plants for companies, and fertilizer plants frequently have ammonia coming out. So the ammonia needs to be removed from air, and the way you typically do is by reactive separation. So you let it react with some acid, and you remove the nitrates. So we are setting up a pilot plant for this company, and the place where we are setting it, the previous professors had some stuff there. And the problem was, nobody knew there what was hazardous, what wasn't. In a situation like this, what happens? Everything is treated as hazardous. And the cost of removing it was exorbitant. You would not believe that. So finally, what the university did was we figured out what was hazardous and what wasn't, and we disposed it of separately. Otherwise, if you were to just dispose it out one shot, I mean, the cost was just unbelievable. All right, so that's exactly the situation you don't want to be in. You do not want to be dealing with waste costs as far as possible, because those could really get very, very high very quickly. All right, so really this is essentially where we are. This is the same plant. This is the same process flow diagram that I showed you previously for getting calculating the fixed cost. We can go through this again, calculate the operating cost. I'm actually not going to do that because I think, again, as I said, the process is relatively straightforward. There's nothing really to it. But nonetheless, I hope what these lectures have given you is an idea of how it is done. You will never really learn it unless you do it yourself. And that's why, as I said, I'm going to give you a quiz, a take-home quiz for you to do this. Any questions? So if anybody kind of asks you questions about how do you cost a plant, do you think you're in a place where you can answer the questions? Yes? Sorry? No, I'm not like an interview. Let's say somebody says, okay, well, you know what? Give me a 2-minute summary of how do you go about costing, how do you figure out the capital cost and operating cost of the plant. What will you say?
I need to pull up this PowerPoint.
Sorry?
I said, like, give me a minute to pull up the PowerPoint.
I'll bring my textbook to the interview.
I'll go slide by slide and be like, I need to do this first.
He will say, okay, you'll get a call from us next year, whether you get a job or not. 2-minute summary, come on. Anybody? Well, just tell them that you split the cost into capital cost and operating cost. And the capital cost, right? You should know a few terms. You should know what is FCI, fixed capital investment. You should know what is the bare module cost. You should know what is the total module cost, right? You should roughly know what is the bare module. What's the ratio of bare module cost to the actual cost of the equipment, roughly?
18%.
3 to 4. You need to remember that, right? That if you know nothing else, you say, well, you know what? You can figure out the cost of an equipment by either a correlation or you call a vendor. You multiply that by 3 to 4, you get the bare module cost, you add them all up, and you get the cost of the plant, right? Now, of course, you could say, well, if you don't want to call a vendor, then you need to work a little bit more, right? You need to figure out B1, B2, FMFP, and multiply all that. And then, of course, you need to also know how do you figure out the cost of manufacturing. You need to know the FCI first. You need to know how much it costs to build, because the operational costs are actually proportional to that. And then you need to figure out the labor costs, you need to figure out the raw material costs, you need to figure out the waste treatment costs, and from all of these, you can figure out the cost of running it, and that's it. Right? Does it make sense to everybody? Now remember, neither I nor anybody will ask you to remember these equations or write these equations. These are not any equations. These are relationships, these are correlations based on historical data, right? Equations, I like to think of equations as something more fundamental. So really these are just relationships based on historical data. You'll find slightly different relationships in different databases, right? You'll find different values for cost in different databases. But what is important is for you to kind of understand, first of all, for you to get a flavor of how costing is done. And also to realize that it's actually very, very important. Okay? It's important not just because you'll have to someday design a plant. It's important because even if you don't have to do that, wherever you are, some point in time you may have to cost something. Most likely it will not be an entire plant, not unless you work for a design company. But almost certainly you'll have to sometimes cost a unit operation, you may have to cost of installation or things like that. And so it's very important you have a good idea of how it is done. So do you all feel comfortable with this? Yes? Yes. All right, so as I said, I'm really not going to go into details. I'm not going to calculate anything, but I'll just show you the information you need. You need the process flow diagram, which is here. You need all the details for all the summaries for all the streams. These are all the stream information. These are all the equipment information. And with all this, you can actually calculate the cost of manufacturing. Okay, everybody's good? Okay, so I'm going to upload these 3 sets of slides and also I'll upload a take-home quiz. How much time do you need for this take-home quiz?
We have career fair next week, so like 3 weeks at least. You gotta take into account like
The other
info
question I
sections
have
and
is, would you like to do this in a group or individually?
Group.
Everybody prefers group? Most of you prefer group? What? Yeah. You're raising hand? Say something?
No, I thought you were saying how many prefers group.
Oh, okay, yeah. So is there anybody here who really doesn't like the idea of doing it in a group? Okay, so everybody likes groups. But we're going to keep this group to be a little bit small because there is really not that much work here. So we're going to make this 4-student group. Okay? So the take-home quiz is a group assignment, and you can have a group of 4 students. Now you do have to make a promise to me. The promise is that you will not just pick your closest friends and make the group. Okay? Try to at least have 1 or 2 people in your group, somebody you don't know. Okay? For 2 reasons. One is, for 2 reasons. One is because that way you just get to know more people, right? But second also, that way you learn how to work with people you don't know. Because that's what you'll frequently need to do once you actually get into industry. And third reason, if you have a friend in your team, he or she is not working, what are you going to say to him or her? If it's a stranger, you will say, what? Or you get 0, right? For all those reasons, please make one of the people.
Wait, what is that for? Is that for
Alright,
IPPD?
have a good weekend. I'll see you
Or is that what you did at
It's everything.